Today we're going to be looking at Module 11, Lesson 3, which covers angle relationships with parallel lines. These are some really cool concepts, and if you learn the vocab associated with it, it's a super easy lesson. If you do not learn the vocab associated with it, well, then there's going to be that too. The textbook's claiming this is a 2-day lesson. We have 17 resources to get through. Let's get into it. Looks like we're starting with a gymnast. And there he goes. And he's on parallel bars. Parallel bars are two bars that extend forever and all time and eternity without ever touching. Only these don't really go for all time and eternity. Let's see what they say. In the Summer Olympics, men and women both compete in gymnastics. There are 2 gymnastics events involving parallel bars. Women compete using the uneven parallel bars, while men compete using the even parallel bars. The uneven bars are a set of 2 bars, one that is 5 feet 5 inches above the floor, the other is 8 feet above the floor. The even parallel bars are each 6 feet 6 inches above the floor, so that's still pretty darn high. Moving forward, it says, can you identify the sets of all the parallel line segments in the apparatus shown? I would hope so, but we're not going to waste time doing that. The introductory question says, what are the angle relationships formed when 2 lines intersect 2 parallel lines? We get to use another web sketch to look at it. It says, study the sketch below. How do lines DE and GA, so you've got DE as the top horizontal line and GA or the bottom horizontal line, okay? How do they relate to each other? They're parallel, okay? How does line FH relate to DE and GA? Well, FH, this one right here, cuts across both of them, and we call that a transversal, which I'm confident they're going to define for you later. How many angles are formed at the intersection of the 3 lines? You've got 1, 2, 3, 4. 1, 2, 3, 4. So you have a total of 8 angles. And the last question, which angles appear to be congruent? Well, I'm looking at it. I'm thinking that this one and this one are going to be congruent. This one and this one are also going to be congruent, and they look like they're probably congruent to the others on the other side. Likewise, the big obtuse angle here and here are going to be congruent, and here are going to be congruent, and these 2, once again, look like they're going to be congruent to those 2 right there. Let's see what we learn next. Lines DE and GA are parallel, just like we thought they were, and line FH intersects them. How many angles appear to be congruent to line FCE? So we're going to take and highlight that. That's a question. Name them. Name the remaining angles that do not appear to be congruent, and how many, and how do the measures of those angles relate to another and one another and measure of angle FCE. Okay, so we got multiple questions here. I'm not going to highlight the name of them, but we are going to take and say highlight that part, because that is going to be another really important subpart here. So let's take a look. First off, FCE is what they're starting us with. That's this angle right here. It appears to be congruent to this one, which is DCB. It also appears to be congruent to this one, which is CBA, and to this one, which is GBH. So if I take and zoom out a little bit, and let's see here. We have FCE is going to be 72 degrees. Now, I'm going to take and do the next one. I thought DCB, that is going to be that one. It's 72 degrees. Now I'm going to look at CBA, which is that one. It's 72 degrees. And I'm going to look at GBH, which is that one. These are all 72 degrees. All the other angles listed do not appear to be congruent to the 72 degree angles, but they do appear to be congruent to each other. Let's take a look at them now. We've got DCF, which is going to be 108 degrees. We have what's the next one going to be? We've got ECB or ECB right there. That's 108 degrees. We got GBC, which is right here, GBC or CBG 108, and then we have ABH right there, 108. So those angles are all going to be congruent as well. Now, while we're looking at that, what does 108 plus 72 equal? It equals 180 degrees, because when these two angles are stuck together, they form a straight line, and that's known as being supplementary angles, which we're also going to be talking about in this lesson, I suspect. From here, the textbook's wanting to ask you about how many pairs of vertical angles, but they haven't defined that yet, so we're going to skip that one, and then we're going to take, let's just skip on in and actually get into the actual definitions of this lesson and learn how everything works. Pairs of angles can be classified by their relationship to each other. A special case occurs when two lines intersect in a plane and form a right angle. These two lines are called perpendicular lines. So right here we have two lines. They're going to be perpendicular lines. I'm going to highlight it right here, and then we're actually be green. And then right here we're going to highlight that because that's the definition that goes with it. Special notation is used to indicate perpendicular lines, and you can take and read the little L right there as line M is perpendicular. Line L is perpendicular to line M, and you can see right there how they have actually written out that you can read that. So I'll use the little red square. Should be no major revelations going on with that red square. You should be familiar with that to indicate a right angle. And using the symbol says that line L is perpendicular to line M. Easy math here. Let's see what else they have for us. Two lines in a plane that never intersect are going to be called parallel lines. All right, that should not be a huge revelation either. A line that intersects two or more parallel lines is going to be a transversal, and I mentioned that to you earlier when we first looked at that. Special notation is used to indicate parallel lines, read as line ST is parallel to line S is parallel to line T, and you can see right here that's exactly what they did. Line S is going to be parallel to line T. Now I'm going to move through some slides and learn how the relationships between parallel lines and their transversals. Zoomed out a little bit, line S and line T, those are going to be parallel lines. Good so far. And you can see they each have that one little pink arrow in there, which indicates these two lines are going to be parallel together. Next, okay, there's arrowheads that says they're parallel, very good. And then finally, line R is going to be your transversal. It is the line that intersects both of your parallel lines. Now, when a transversal intersects two parallel lines, 8 angles are formed, and we talked about that earlier as well. The four of the angles are going to be interior angles, and they're located in between the parallel lines. So we're going to take and highlight that, and you can see angle 3, 4, 5, and 6 are all going to be interior angles. For the angles that lie outside the parallel lines, those are going to be the other vocab term, exterior angles. Angle 1, 2, 8, and 7 are all going to be your exterior angles. Now let's select buttons to see it. All right, so bing, there's your interior. Bing, there's your exterior, just like I just told you. When two parallel lines are cut by a transversal, there's a relationship between the angles that are created. The angles created are certain pairs of alternate interior, alternate exterior, and corresponding angles. So we're going to take and highlight all of those because you got 3 different terms we're going to be defining down here, and they all have these. I will say they don't all have the same angle measurement. The alternate interiors measure the same, the alternate exteriors measure the same, and the corresponding angles, those measure the same as well. So let's take a look at the special notation right here that says that somehow I'd highlighted more than I should have. Let me clear that out and highlight just what I want this time. So right there is what I want. The special notation says that M angle 1 is referred to as the measure of angle 1. Okay, we good so far? Let's take a look at our layer controls. First, your alternate exterior angles. You can see the single pink lines for 4 and 6. That's also alternate interior angles. The single pink lines for 4 and 6 means that those two angles are congruent. They're the same exact size. Your other alternate interior angles are angles 3 and 5. They have double pink lines, which means that those two angles are going to be congruent to each other, but they're not congruent to angles 4 and 6. Next, let's look at the alternate exterior angles, where you can see angle 2 and angle 8 have a single pink line. Angle 2 and 8 are also going to be congruent. Angle 1 and angle 7 have a double pink line, meaning angle 1 and angle 7 are congruent. This is always going to be the case for alternate exterior angles. Finally, we have the corresponding angle, and the corresponding angles are angle 1 and angle 5. The corresponding angles are on the same side of the transversal and the same side of the parallel lines. So angle 1 and angle 5 are going to be congruent, their corresponding angles, and angle 2 and angle 6. Those are going to be congruent as well, their corresponding angles. But obviously angle 1 is not going to be congruent to angle 6. Now we're finally into our examples. Example 1 wants us to classify the relationship between angle 1 and angle 7. Well, first thing I'm seeing is that they're on alternate sides of the parallel line. Opposite sides of the transversal, and they're outside or exterior the parallel lines. Let's see how they want us to go through actually doing this, because I'm seeing that they're alternate exterior. It says boom, 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 they are going to be alternate exterior, just like I just said they're going to be. Let's move on to the next one. Now we're going to take, it says name another pair of alternate exterior angles. Well, that would be angle 2 and angle 8. Those are also going to be alternate exterior angles, and that's going to be it for that. Let's get into extra example number 1, where you're going to pause the video and answer the question on your own. Go. We're looking at angles 4 and angle 6. 4 is right here, 6 is right here. They're on alternate sides of the transversal, and they're interior of the parallel lines. That means they're going to be alternate interior angles. Check our answer, and our answer checks. Let's keep going. Example 2, classify the relationship between angle 2, which is here, and angle 6, which are here. These are going to be on the same side of the transversal and in the same relative position of the parallel lines. So our answer to that one is that these are going to be corresponding angles. Check that. That one checks. And now you do extra example number 2 on your own. Go ahead. Classify the relationships between angle 4 and 8. So 4 is right here, 8 is right here. They're on the same side of the transversal, and they're in the same relative position on the parallel lines. That means that these two are going to be corresponding angles. Super easy stuff here if you just learn the definitions like I told you earlier. We're going to end this lesson at this point, come back and watch part 2, where we're going to learn how to find the missing angle measures. I'll see you in part 2.